Hello guys, for this presentation, me and Tyler looked at does minimum wage affect unemployment rates? Our motivations for this project. So this paper will look at if there's a correlation between the minimum wage and unemployment. This is something we care about because many college students work minimum wage jobs during school and we need a steady income in order to fund our schooling. With many cities such as San Jose rising their minimum wage over the upcoming years, we want to predict the possible effects of these increases. Basic economics says that minimum wage will increase unemployment. However, a famous 1994 study showed no increase in major unemployment when minimum wage increased. According to a study conducted by UC Berkeley professor David Card and Princeton professor Alan Krueger in 1994, comparing the minimum wage increase in New Jersey to the lower minimum wage in neighborhood Pennsylvania and found that unemployment did not increase in New Jersey as economics thought it should have. However, this study has been consistently questioned for its use of only fast food restaurants along with very short scope of time to observe the changes in unemployment. While the increase in pay would be great for us students who also work part-time job, losing a job or being unable to find job would be a huge threat to affording our education. Minimum wage increase will not solve the unemployment situation. Companies cannot afford to pay workers these high wages if their productivity does not value them at the higher wage imposed by the government. Minimum wage is viewed as a prime example for price floor and creates a surplus of workers, which in turn should cause higher unemployment rates. For the variable side of this project, we use minimum wage and the labor force as our independent variables and unemployment as our dependent variables. These were measured by looking at the unemployment rate in percentage, labor force in thousands of civilians, and the minimum wage in dollar hours. Table 1 showed the descriptive statistics of each variable. The first row of the table shows us the unemployment rate statistic from all 50 capital states. Here we see the lowest unemployment rate is in 2017 was 2.2% in Honolulu, Hawaii. The average unemployment rate for all 50 state capitals is 3.77%, while the highest unemployment rate was 5.2% in Charlestown, West Virginia. The second row in table 1 shows us the minimum wage statistic of the 50 states in 2017, which is measured in dollars per hour. The lowest minimum wage was $7.25 per hour, which is set by federal law and occurs in multiple states. The mean minimum wage was $8.39 per hour with a high of $11.09 in Santa Fe, New Mexico. This data was collected from 2017 and many capitals have increased their minimum wage over the past year. The third and final row in table 1 shows us the civilian labor force of 50 state capitals in 2017, which is measured by the number of civilians. The low labor was 4,948 civilians in the labor force, which was Montpelier, Vermont. The average labor force was 539,196 civilians with a high of 3,034,633 civilians, which occurred in Atlanta, Georgia. This slide will look at where we got our data from. We found our unemployment rates, labor force, and minimum wage data using the Bureau of Labor Statistics website. From this page, we went through each of the 50 states and chose their state capitals as a test city. Since the BLS gathers data from all 12 months, we had to download the back data from 2017 as an Excel file and then use the auto sum function. This allowed us to find the average unemployment rate in the chosen city for 2017. Unemployment rates are measured in percent of civilian labor force looking for work. For United States, for states with minimum wage that vary by county, we used minimumwage.org, which provided us with local minimum wages. The data for minimum wage is measured in dollars per hour and is the average wage for the year of 2017. Our data size was 50 state capitals. In the first specification, we regressed unemployment rates on the minimum wage. The first regression showed that in 1 unit increase in the minimum wage would have a 0.18367% increase in unemployment rates when holding all other variables constant. For our second specification, we regressed unemployment rates on the minimum wage along with labor force. Our second regression showed that a 1 unit increase in labor force would cause the unemployment rate to decrease by 0.002895% when holding all other variables constant. By increasing minimum wage, we'll increase unemployment even when we add in these other factors. For our third specification, we regressed unemployment rates on minimum wage along with the labor force and the region of the country the city was located in. We are comparing these regions to the Midwest region, which we left out of our regression. Our third regression shows that the West region has a 1.8181% higher unemployment rate than the Midwest. The Southwest region has a 2.51629% higher unemployment rate than the Midwest. The New York, New Jersey region has a 2.41697% higher unemployment rate than the Midwest. The New England region has a 0.472725% lower unemployment rate than the Midwest. The Mountain Plain region has a 0.734058% higher unemployment rate than the Midwest. The Mid-Atlantic region had a 0.078 higher unemployment rate than the Midwest. The Southwest region had a 1.031% higher unemployment rate than the Midwest. And by increasing minimum wage, we'll increase unemployment even when we add in these other factors. For our conclusion, there is a correlation between unemployment rates and minimum wage. Our regression concluded that there is a statistical significance correlation between minimum wage and unemployment rates, controlling of other variables. A $1 minimum wage increase creates 0.18367% more unemployment controlling of all other variables. This shows that new policies that look to raise the minimum wage upwards of $15 will increase unemployment in these cities. Many different reasons lead to unemployment rates in the cities, which create a large possibility that others studies may have been omitted variables based as we only included labor force and regions as other possible factors. So our OLS assumption. First, the linear assumption. The linear assumption is not violated as our first plot is flat and shows no pattern. Second, our independent assumptions. Our data is not time series data and passes the independent assumption. It's a normal assumption. The normal assumption isn't violated as our second plot shows a relative linear relationship, meaning our errors are normally distributed. An equal variance assumption. The equal variance assumption isn't violated as our first plot shows that our residual and relative equal at all predicted values, meaning that we don't have an increasing variance. Thank you.